We introduced the making process, and we spoke about how paper sludge is being generated throughout the process. We also distinguish between paper making from virgin fibers and from recycled fibers. And we also gave an overview of different sludge streams, which are typically generated in average paper mill facility. In this episode, however, we are going to focus on paper sludge from a different perspective. We're going to talk about it as a potential or as a solution to fight the current energy and climate crisis that Europe is facing.
All right, let's see.
So if we take a look through our agenda of today, I will talk about the energy and climate crisis, but also I will focus on the most relevant EU environmental climate policies and the developments. Then I will talk about how paper sludge is currently disposed and what are the limitations, but also what are the points of improvement. And then Karime will take over and she will tell you more about the European availability of paper sludge and what could be done with it. And if we take a different route, what would be the benefits overall?
And the Q&A session, very important.
And at the end, we have the Q&A session indeed.
All right.
All right. So talking about the energy and climate crisis, especially in the last year, we have witnessed how dependent and what are the negative effects of Europe's dependency on Russian energy, but also on fossil fuel energy in general. So here we have some brief basic figures about this topic. The EU currently still imports 90% of its gas consumed, and the Russian gas accounts for almost half of that. We also have 27% of oil imported and 46% of coal being imported from Russia. And it's not only the natural gas that has witnessed extremely high prices, but it's also the electricity, because the two are directly tied. So besides the regular household consumers like you and me, we also have the energy intensive industries such as cement industries, steel industries, but also paper mills and agri-food sectors, which are suffering the most from the recent developments. For this reason, to tackle the response towards this, the EU has come up with a sort of set of legislative proposals and amendments, and it's all called Fit for 55. And basically, the main goal of this set of policies is to cut the greenhouse gas emissions by at least 55% by 2030, compared to 1990 levels, and ultimately to reach the climate neutrality by 2050. So as we can see in the graph, we still have the overview of the main sectors, such as energy and transport and agriculture, and the current CO2 emissions. As we can see, the emissions are substantial, and we still have a long way to go up until 2030 and ultimately 2050. And as a part of Fit for 55, which is also incorporated into the European Green Deal, there are many policies, there are many instruments. However, the ones which are the most relevant for us, we can summarize them as the EU emission trading system, specifically for power, for industry, maritime and aviation industry. Then we have the Renewable Energy Directive, the RED II, but also the upcoming RED III. We have the two brand new initiatives focusing on maritime and aviation sector called Fuel EU Maritime and Refuel EU Aviation Initiative. And if we take a look into these in more depth, we see if we split the topics via energy and transport. In terms of energy, we have the main tool, Renewable Energy Directive. Currently, RED II is the one being in effect. And the overall target for renewable energy has been raised to 32% by 2030. And it also includes a sub-target for transport sector, which obliges member states to require fuel suppliers to supply a minimum of 14% of energy as renewable. This target, the overall target of 32%, has already been proposed to be increased by 40% in RED 3. So even in the next couple of years, we are going to witness stricter targets. Then we have the newest initiative is called the Repower EU plan. And this is also direct response to the previously mentioned dependency on Russian gas, but also fossil fuels in general. So the EU has set a target to produce 35 billion cubic meters of biomethane by 2030. And this would be about 20% of the current Russian gas import. And in terms of transport, for the first time, we see binding targets for aviation and maritime industry. So in terms of volume share distribution of sustainable aviation fuel, the aircraft fuel suppliers, they need to, starting from 2% in 2025 all the way up to 2050, they have to supply 63% of sustainable aviation fuels in their shares. And also the EU airports, they must be able to provide the necessary infrastructure for storage and for refueling of SAF. On the other hand, in the maritime sectors, we have greenhouse gas reduction targets, and this is valid for vessels larger than 5,000 tons capacity. So again, starting from 2% in 2025, but going all the way up to 75% in 2050. This would be the summary of the legal framework, and these are still goals we can reach them, but there's enough work to be done, and we will see what can be done from the perspective of paper sludge and how we can incorporate that into the whole story. Okay. So before we dive deeper into the current disposal of paper sludge, first I would like to say a few things about the anatomy of paper sludge. And this is simply to show you, to understand what are the limitations with the current approach and maybe what could be the more suitable way to handle this type of waste material. So just some facts. As a residual material, paper sludge has a high lignocellulosic content. So on average, we talk about 40 to 60% of cellulose. We can have traces of lignin depending whether the sludge derives from virgin fiber making process or a recycled fiber, and we can have 0 to 60% of ash on dry basis. And just a short recap, so during the paper making process, the cellulose fibers, they're isolated, and the goal is to make them come together and to form a strong network, so basically to create the structure of paper. However, during the processing, some fibers, they get partly degraded and they also shorten in length, which basically makes them fall through the paper making machine, the wire, and they end up being discarded. And this is what we call in DBG paper sludge. And this type of fibers, they have, because of their structural arrangement has been already interrupted, they have extremely, they have open hydrogen bonding, and they're able to hold extremely high quantities of water. So even though if you look at the material and as a solid, it might look like it's solid, but it can have 50 to 60% moisture inside. And also because of this hydrogen bonding and high water holding capacity, we have a very high viscosity of the material, which, to translate it to practical terms, in terms of mechanical processability, pumping and mixing, they become very difficult processes. And in addition to that, some cellulose fibers, they can physically be protected by lignin, so we can have reduced biogas yields of the material. That would be the overall introduction. And if we take a look into the currently most commonly applied solution, which is co-incineration or co-combustion of paper sludge with another type of substrate, typically municipal solid waste. Here we have a case study in which we have a plant capacity designed to uptake 270,000 tons of incoming material per year. The maximum that we can blend paper sludge with another feedstock, in the best case scenario, we talk about 25% versus 75%. And this is mostly because the high moisture content within the sludge, it negatively affects the ignition and the combustion characteristics, but it can also damage the incineration boilers. So it's not the most attractive feedstock to burn from a technical point of view. From energy feasibility point of view, in this case, the material had incoming low heating value estimated at 6.3 megajoule per kilogram. And throughout the incineration process, we have the main product being steam. And then potentially, if we convert that steam into electricity, we end up degrading the energy potential. So we go from 6.3 to lower. And we downgrade the product. And the future disposal price, because it's a material which is not very attractive to burn, it also has unpredictable prices, and probably those will continue to rise because of the CO2 taxes and because of the current legislations in which direction they're going to. This is going to be more and more limited. This is the same process, just a visual overview. And one other thing that is important to mention is we also have high quantities of byproducts produced, such as bottom ash and fly ash. And whereas they do have use in terms of construction sectors, we also have flue gas residues, which is something that has to be tackled and dealt with because it's full of compounds which can be toxic to human and environmental health. And important to say again is that we have to keep adding more burnable substrate or more coal to maintain the heating process. And in this table, we have overview of, in the first column, we see the most important parameters which we thought should be compared. And then we have the already mentioned co-incineration of paper sludge. But we also have certain other waste to energy processes, such as pyrolysis, gasification, and torrefaction. And then we have landfilling at the end. One thing that is important to look at is the temperature range, which implies the amount of energy that has to be used in order to sustain the process. We have in the best case scenario between 200 and 300 Celsius degrees, but it can go up to or above 1000. The volume reduction is not 100%, which means that even though you have main products the paper sludge is converted into several main products, you also have byproducts or pollutants, which again are constrained and they have to be dealt with. And oftentimes they are not, they don't have stable markets and they come with a negative value. And if we look at the main products and the respective columns for those, and then if we focus on the last row, which is about the heating values of those end products, we see values going from 2 to about 30 megajoule per kilogram, best case scenario. So that would be the most efficient process. And lastly, we have landfilling, which in Europe is becoming increasingly more restricted method of disposing paper sludge. And landfilling is also known to emit methane into the air, but also it can cause leachate. So especially, for example, we are based in the Netherlands, which is a country which has a very low groundwater table. Leachate can lead to saturation of groundwater with nutrients, and you can have eutrophication, all kinds of problems on the downstream side of the process. And to briefly give an overview about most commonly found pollutants. So we have different groups of pollutants. Some of them, such as the volatile organic compounds, they're toxic, they're carcinogenic. They also cause the ozone depletion. And for example, their lifetime is between 3 hours to 1.5 months. But then we also have the NOx precursors, hydrochloric acid. These are all very powerful pollutants because they can form acid rain and they can harm sensitive ecosystems, and they have extremely long lifetime. Then we have methane, which is on average 28% more potent than CO2. And basically it forms the ground level ozone. And we have particulate matter, again, related to negatively to human health. And we have leachate, as it was previously mentioned. And now I will leave you in the hands of Karime to talk about the availability and the potential of paper sludge.
Thank you, Lara. Yes, indeed. Now that Lara mentioned, or she explained basically the current situation that Europe is facing in the world concerning energy and the climate crisis, and also just a brief overview of what options there are nowadays to dispose of paper sludge, I will tell you a bit more on how much actual paper sludge there is at a European level. How much it's being produced, and also what exactly can be done with it aside from what is already being done. So first of all, here you have a graph a graphic representation of data that we obtained from the CEPI, so the Confederation of European Paper Industries. And this is for you to see at the very end. You can see that there's 14 million tons of paper sludge produced in Europe per year, as I said. And then here it's important to see that Europe has quite high recycling rates. And this is directly linked to the high amount of paper sludge produced from the recycling. Since, well, Lara already explained that the more you recycle the paper, the shorter and shorter the fibers become. So it is, it's logical that there's a higher paper sludge production from the recycling than from the virgin fibers that we can see on the left side, that it only amounts to 3 million tons. And in total, it's, the total paper and board production is 90 million tons per year. So that is how much there is available nowadays. But there are quite some challenges that come with this material. So first of all, the high CO2 emissions from the current, processing methods that also Lara just explained. Then we also have the mechanical processability that is quite a challenge for machinery to tackle, and the reduced biogas yields that we have due to the lignin content of the paper sludge. Furthermore, most of you have probably faced some issues or some pressure from governments or governmental organizations that more and more demand to reduce the fossil fuel use and to have a higher production of green gas. And finally, also concerning the agricultural sector, the emissions from artificial fertilizer production demands also for a shift towards more high quality and organic mineral fertilizers. Now, a little bit of an introduction to the company. We are DBG Bioenergy, and we're an Amsterdam-based company that was founded in 2019. And the main drive for the foundation of this company was in response to the urgency of tackling the challenges that the paper industry was facing, as well as the contributing to a solution for climate change. Now here you can see a snapshot of our process, and this is based on our business model for our first plant located in Delfzijl in the north of the Netherlands. And so we will be processing 270,000 tons of this material, of this paper sludge per year. And this material will enter our pre-treatment enzymatic process, which is at mesophilic conditions, so aerobic and 37 degrees Celsius. Then from this, it lasts about 2 days, so 48 hours. After that, it enters normal off-the-shelf anaerobic bioreactors, where the retention time will be 25 days. And from here, there's going to be biogas production. The biogas will be split into CO2 and methane, and both will be compressed and liquefied, bringing us to the numbers that you can see over here. The bio-LNG, which is the methane being liquefied, there will be 14,000 tons produced and 35,000 tons of liquefied biogenic CO2. Now, a challenge that some companies that also deal with the sludge and anaerobic reactions face is the digestate. So instead of being a waste product within our system or within our process, it actually becomes the starting point for further production or further processing to create or to produce 180,000 tons of green fertilizers. So there you can understand, or you can see how the loop is completely closed. Now, as I previously mentioned, the challenges that just surround paper sludge, the solutions that DBG is bringing is, for instance, with the high CO2 emissions, we offer an alternative processing method using enzymes that and the anaerobic digestion that is already being used for quite some time. Concerning the mechanical processability, what our method does is that it decreases the viscosity significantly. So we will have sludge entering with 20,000 centipoise viscosity, and it gets reduced all the way to below 2,000 centipoise. This also will improve the biogas yields up to 60% compared to the untreated paper sludge. Furthermore, concerning the pressure that governments or the need for companies to reduce these emissions, we contribute also to the green gas and emission reduction targets by producing the, as mentioned, bio-LNG and used to replace fossil fuels in heavy mobility applications. And finally, the emissions from artificial fertilizer production, these would be tackled by us upgrading the digestate from the anaerobic digestion into green fertilizers used for the agricultural industry. And this is the bigger picture. So this is the same graph that was presented earlier by Lara, but then here you can see also the DBG data. So our process in comparison to the rest is lower. The temperature is between 36 to 65 degrees Celsius. The volume reduction is almost 100%. And our final main products, so to say, is the bio-LNG, the fertilizers, and the liquefied CO2. As for pollutants, there would be none because indeed we do closed loop within our process. And finally, here you can see as well that the heating value of the end product, it gets upgraded. So it starts between 11.2 based on our mix, and I will further explain that. But it starts from 11 something and then gets upgraded because it turns into bio-LNG. And that is where the link of the heating value comes from. 50 megajoule per kilogram. Now, at the beginning, we presented a case study with co-combustion. And here also you can see it compared to the DBG case study. So it's the same amount of paper sludge. As I mentioned, 100% of this material would be processed. Concerning the impact of high paper or the moisture of the paper sludge, it doesn't necessarily play a role in our process since it's already a wet process, or there's no combustion per se. And also, as I mentioned earlier, here you have the initial heating value versus the end one being produced, or producing the bio-LNG. And as for the emission savings that this process would entail, it would be roughly 75,000 tons of CO2 equivalent per year, emissions that are not being put into the environment. And yeah, as for the future disposal price, in this case, it would be just stable and reliable. So moving on, once again, you have the graphic representations of both processes. And yeah, here, once again, you can see that the products, or yeah, the products being produced, these are very marketable and yeah, in high demand products that we will be yeah, bringing to the market. Now, as for the theoretical potential of this, what does this mean? How can we bring this into tangible impacts? With the 14 million tons of paper sludge being processed, let's say with DBG solution, that means that we would be producing 1 billion cubic meters of biomethane, and this would be equivalent to powering 2 cities the size of Amsterdam for an entire year. As for the liquid CO2, just as a background information, this is a key element or a key component of the sustainable aviation fuel. So with this process and with this amount of material being processed, we would almost produce enough to fuel over 4,000 transatlantic flights, meaning from Europe to North America. And finally, with the fertilizers that would be delivered, then it is the equivalent to covering 55% of the total demand of fertilizers in the EU. Finally, here you can see you can see 3 graphs, and this is the atmospheric concentration of of greenhouse gases in the atmosphere. And you can see here that it's still increasing. So this means that there is, there's a high need for companies and for other organizations to implement measures and to abide to these measures that basically will stop and reverse the concentration of these gases in the atmosphere, and hence also pull a brake on climate change and global warming. Furthermore, as Lara explained earlier, there's very ambitious goals set by governments, but there's not that much clarity on how to reach them, which for some it could be a problem, but that also means that there's a lot of room to bring innovation into the picture and come up with solutions that are going to help the environment. So in general, the conclusion would be, don't waste. There's a lot of potential in it. And in this case, that would not be a problem. It would be an opportunity for, in this case, DBG, but also other industries to bring something to the table. Thank you so much for listening to this presentation. And we will give you roughly 3 minutes. Is that okay? Yeah.
3 minutes of time. We will wait for your questions. But also, if you would like to initiate a more in-depth discussion, feel free to note down our email addresses. And we are always looking forward to connecting or discussing these kind of topics. Thank you.
Thank you. All right, we're reading over your questions. So we're gonna start with the very first one. And just checking that I'm not muted. Yes, I'm good. So we have some plastic contamination in our paper sludge. Does it interfere with your process to produce gas or fertilizers? Lara, would you like to answer that?
Right. So what's important to say, our enzymatic process is designed in such a way that the presence of plastics does not negatively affect it. But also we have, this is very common. So you have streams of sludge that they always have some residual plastics. So we have come up with different screening methods already before we even start processing the paper sludge. We already make sure that we minimize the plastic contamination. And I think overall we have, as we have shown you the balance of our mill, we have 270,000 tons of paper sludge coming each year. Maybe 0.x% of that we expect to extract out as plastics. So we have already come up with strategy for that.
All right, second one.
Then we have a second question, which goes, why do you prefer to use paper sludge instead of, for example, cow manure like in other biogas plants?
Okay, well, first of all, we would like to, or we want to help the paper sludge or the paper industry to become more environmentally friendly. So that is one of our biggest drives. But also, considering the fact that paper sludge is a steady, well, it's being produced 24/7. So it is a steady stream of material that nowadays there are applications, but it is a reliable material to count into, to take into account into a process that there's going to be constant need or constant demand for these products to be offered to the market. So it's safe, to put it in short.
Maybe just one more thing to add. So also, as we said, we already spoke about the technical challenges of anaerobic digestion of paper sludge, and we have two main ones, which are the mechanical processability, but also reduced biogas potential. But actually, paper sludge, as it comes in, has on average 4 to 5 times higher energy content than manure. So as soon as we tackle those challenges related to processability, we have access to more organic matter and energy potential, and our process is quite efficient in terms of biogas production.
Okay, next one. How has the trend of paper sludge production been the last years? Has there been a decrease? Has there been a decrease in this production because of the digitalization?
So in the last couple of years, indeed, like we are using more screens at work, at home. So what we have witnessed is that the printing paper production has decreased, but also because of digitalization, we have more packaging paper increase, and this is because of deliveries. So nowadays we are ordering more products online. Overall, there are more shipments. So, for example, production of cardboard paper has witnessed an increase, and currently we have the ban on single-use plastics,
of course.
So instead of using plastics, a lot of shops, for example, they rely on use of paper cups instead. So overall, the volume of sludge produced is not expected to reduce significantly.
Yeah. Okay.
Maybe so we have a technical question, which is about what is the biogas yield per kilogram of paper sludge, and what we can get out of the technology.
Okay, it's if I'm not mistaken, it is between 100 and 150 liters of biogas per kilogram of wet paper sludge. Yeah.
Okay.
Let's see, we're scrolling. Yeah. Okay. Yes, here. Are there any byproducts of residuals from the paper mill process that could be of concern in regard to uses for fertilizer after biogas production or biological byproducts during anaerobic digestion?
So we take extreme care into whatever we accept in our facilities, and each stream of paper sludge we screen initially for biogas potential, but also for all the commonly found contaminants, such as, for example, the heavy metals. So our screening process begins right at the entrance of the plant, and we have several sampling points, and in the end we ensure that the outputs, whatever the output product is, that we are compliant with the relevant EU regulations.
Yeah.
If you excuse us for 1 minute now, we have a lot of questions coming in. So it's very nice to see the interest, but I think we also have to organize ourselves a little bit.
Yeah.
So maybe 1 or 2 more minutes, and then we will do another round of Q&A.
Yeah.
Thank you.
All right. So we will continue and we will answer roughly 2 more questions. And yeah, again, if you have sent a question but we haven't answered it, please feel free to contact us directly. Or if you have questions at a later stage, again, feel free. So shall I?
Yes.
What are the nitrogen and phosphorus levels in the paper sludge? I think you can answer that one.
So in primary paper sludge, which is the most commonly paper sludge found at the paper mill, it is the one that we have spoken about. It is the one which is rich in cellulose fibers, but it could also have traces of lignin and certain amount of ash. By nature, this type of stream has low quantities of NPK. And this is something that is we see often, and we expected. We know that's the characteristic of this type of stream, but also DBG's process includes, it's not based on one type of sludge only. So we actually, what we do, we accept multiple sludge streams. Some of them are primary sludge, some of them are secondary sludges. They all have different levels of NPK, and in the end we find out that the balance works the best. So if we mix primary and secondary sludge at a certain ratio, we get the most optimum NPK for the entrance. But that's roughly the answer.
All right.
Yeah. And now we have a question regarding our first site in Delfzijl. So it's a question of what would be like the main challenges that we are facing in realizing the first site, but also what are the main challenges to scale up to those 14 million tons of sludge processing that we have explained.
Okay. Well, by far, the permitting process was quite time and resource consuming. I also believe that that's because it's quite a niche industry, so there's not that much being done like this process. So there's extra information that needs to be given and extra steps sometimes So definitely the dealing with the permitting has been a challenge, but still we're getting there.
Yeah.
So,
and the challenges in the construction industry,
indeed, of
because
course.
of the steel production, again related to gas prices and energy crisis. So that would be it.
Yeah. Okay. I think that's
yeah, I think that's it. We don't see any new questions coming up now, but once again, thank you very much for your attention and patience. And as Karime mentioned, please initiate the discussion with us. If you come up with the question later on, we would like to hear from you, and we would like to invite you to join us in our next series as well. We will announce on LinkedIn when the next episode will be.
All right. Thank you so much, everyone, and have a great day.
Thank you.
Bye-bye.